everything you learn in this class has a dimension, and you need to know how to derive them from their definition. Right? Now, let's say I am compressing a spring with natural length, let's say 2 meters. And we compress it until it is 1 meter long. Okay? Originally it is longer, it's 2 meters, and then we compress it until it's 1 meter. So the amount of distance that we compress will be how long? If we compress it from 2 meters to 1 meter, how much we compress it?
1 meter.
Good. So the spring force will be the spring constant times 1 meter. Now, if K is bigger, will spring force be bigger or smaller? If K is bigger, will the spring force be bigger or smaller? Bigger. Good. If K is bigger, Fs becomes bigger. Right? So, if a spring has a big spring constant, does that represent a stronger spring or weaker spring? Good. K is the property of the spring. And it's kind of represent how strong a spring is. Because the bigger K is, the bigger the spring force under the same compression. Okay? So that's all about spring that I want to mention. Next is our final topic for midterm, which is actually using physics in real life. We learn physics because we can use it in real life and it will work. So let me demonstrate how exactly we're going to use them. So we derive that if I throw a projectile with some initial speed v naught and an angle theta, it will fly to a distance, I call it d, and we derive a formula for that in the lecture, which is initial speed squared times sine 2 theta divided by g. So the only reason we want to get it is because we can use it. If I know the speed that the projectile is launched and the angle of it and g, I can predict how long this thing will be shooting. This is a projectile launcher. Okay? So the first thing I need to do is to figure out how fast is the speed when this thing launches the projectile. To measure that, you can take a high-speed camera and record it going out and figure out how long it moved with a short time, but do not have a high-speed camera. So what I'm going to do is use the flight time we derived. Flight time is the time it takes from launching to hitting the floor. And it is going to be so initial speed vertically is v naught sine divided by g, which is the time it takes to go to the top, and you need to go down, so multiply by 2. Anyway, we derived this formula for the time it takes to fly to the air. So, if I multiply t flight with g and divide by 2 sine theta, that will give me the initial velocity, initial speed. Okay? So let me do that. I'm going to set this to 90 degrees up. If you have any stopwatch, you can do it with me together. We're going to measure the time it takes for it to launch out and then drop down. That will tell me how fast the projectile is launched when I shoot it up. Okay. Ready? 3, 2, 1. So I get 0.98 seconds. Did anyone measure something?
0.97.
0.97. Any other? No, okay. Now, you can see my result in Jean is different. So this number is not accurate. I can only round it out to 0.1 second because we know our human hand and human eye cannot measure that time accurately down to this one. You can see our result is different. Okay? So when I write it as 1.0, it means I'm sure it's 1.0, but I'm not sure if it is 1.01, 1.02, or 1.00. That's why I do not write this number. That's why I do not write this digit for 0.01 second. Okay? So how do I get initial speed? What is this angle here when I shoot it vertical up? 90 degrees, good. What is sine 90 degrees? Good. So V naught will be 2 times 1 because sine 90 is 1. T flight is 1.0 second. Gravitational acceleration will be 9.8 meters per second squared. So you get 1 times 9.8 is 9.8. That divided by 2 is 4.9. And for the unit, I have meter per second squared. I have the second for 1 second. I have meter per second squared from the acceleration. So you can see the second and the second in the denominator cancels, and I get 4.9 meter per second, which is a unit for speed. So when you are using real numbers with units, just write down the number and unit at the same time, and cancel them like you're doing algebra. S cancel S, and meters as, so at the end you get meter per second, okay? Good, now we have our initial speed. Let's try to aim at something. Because with this formula, we can calculate how long the thing will shoot out. I'm just going to randomly pick an angle. Or do anyone have a favorite angle? In case I'm cheating. Okay. Let me go higher so you can fly longer and it's more dramatic. right now, the angle is 68. I can only write 68. I cannot write 68.0 or 0.00 because the projector over here only had scale down to 1 degree. There's no way I can measure this angle more accurate than just 1 degree, so that's why I keep it as just 68. When you write numbers and those numbers are something in real life, the amount of digits you write has meanings. Mathematically, 68 may be equal to 69.00, but it means different things. This means I know it is around 68. It might be 68.1, 0.2, but I'm not sure. This means I'm sure it's 68.0 and 0. And I'm not sure about the extra digit after that. Okay? Now, according to this, the distance, like the flight, will be v naught squared, which is 4.9 meter per second squared. Sine 2 theta is 2 times 68 degrees. And divided by g, which is 9.8 meter per second squared. So, I need to figure out sine 68 times 2, which is sine 136 degrees. Anyone have a calculator? If you not, I can use my cell phone, it's fine. So you need to bring a calculator for your midterm because you need to plug in numbers. Yeah, Olivia?
I'm wondering why you squared the 4.9.
Because it's b squared.
Oh, okay.
You need to follow the formula.
Okay.
Any other question? Yeah, Jackie?
So, just to clarify, when a projectile is launched starting from the ground and not like something on
You need to derive the formula again.
right, okay.
This formula only works for launching from the ground.
Okay.
If you are launching from a hill, like your homework, you need to do the thing you do from homework. Okay? But I want to emphasize to break the problem into two steps. The first step is to derive the formula, then you plug in number. Because with symbols, you can do dimensional analysis, you can do tendency check, you have all the tools you need.